Hello guys, we are in the last section of this video on momentum, or second to last section rather. And let us look at this. This time around, we are going to be looking at 4 questions on the momentum, and more of these questions are based on the elastic collisions and momentum, basic momentum questions. And let us look at them one after the other. It says what? Number 7 says an object of mass m, So let's call M, sorry for that. Let's call our M1, our M. So let's say M1 is equal to M. Now, then I said what? Velocity V. So let's say U1 is equal to V. Okay? Collide elastically with a stationary object. So for, let's say the M2 is what? Let's say M0. This is the stationary object now. This is stationary object. Then let's say U2 is equal to 0. Why did I take 0 for my U2? Because the body is stationary. Anytime a body is stationary, your initial velocity for that body is what? Is 0. But after collision, what happens to your final velocity of the first body? You now continue to move with what? 0.25. You check the question, they say what? An object of mass m and velocity v collide elastically with a stationary object, which I have interpreted 0, and continue in the same direction with the speed of what? 0.25. So which object is continuing with the speed of what? 0.25 is what? This object, not the stationary object. So what? Don't forget that when they collide, the velocity of this one will reduce, of the first object. So from v it has reduced to what? 0.25. And basically the one that is 0 before will increase, will go up. It will no longer be 0 after collision. What is the mass of the object that was initially stationary? So what we're going to do simply is what? We've known our what? The V1. What do we say about V2? Unknown. Then we have 2 unknown here. We have the mass what? Not known, which we are looking for. Then we are looking for also what? V2. Although V2 is not our focus here. But to look for V2, we can use E equal to what? V2 minus V1 over what? U2 minus U1. Absolute. So when you take this one now, when you use this formula, you can get our what? Our V2 from here. Let's equate everything to be equal to 1. Since we are not giving an elastic what? Collision. So V2 is unknown, which we are looking for. We have V2 minus, what's our V1? 0. V1 is what? 0.25 V over, what is our U1 or U2? U2 is 0. What about our U1 is V, absolute of what is equal to 1. And what we're going to have now is what? We're going to have V2 minus 0.25 V all over what? V equal to what? 1. Because this one will give us 0 minus V will give us minus V. But because of the absolute, it will turn it to plus. And so that's the essence of putting absolute there. You know what I mean? And so that it can counter any doubt. Because our E will always be positive. Now cross multiply, what I would have done? V2 minus what? 0.25 V is equal to what? V. So how do you get V2? Therefore, V2 is equal to what? V plus, collect like terms, 0.2 V, 25 V. And what's our V2? V2 becomes what? 1.25. So I haven't gotten your V to be 1.25 because 1 V plus 0.2 V, 25 V equals 1.25. So after getting your 1.25, the work is now less for us. So this one now is now 1.25 V. So we have gotten our what? Velocity to be 1.2. Final velocity of the second body of the stationary body to what? 1.25 V. Now, what we're going to use now is to use our formula for conservation of what? Momentum. And if we want to do that, let me clean this part, please. If we want to do that now, we just simply going to use our what? M1, U1 plus what? M2, U2 equal to M1, V1 plus what? M2, V2. So in this case now, this is what we are going to use to calculate the velocity or the mass rather now of the stationary body or object. Now M1 is what? What is our M1? Is M. What is our U1? U1 is V plus what about M2? 0. No, not 0. M2 is M2. Why the what? U2 is what? 0. Equal to what is our M1? M1 is Tm. V1 is now what? 0.25 V plus M2, let's say M0. V2 is now what? Times 1.25 V. So 1.25 V. This is it. Now, what I want to do now, this one will cancel out. So we have MV got to what? 0.25 MV plus what? 1.25 M0 V. So what we are looking for is this M0. Now, how do we solve M0 now? Is to make M0 the subject. First of all, collect like terms. So when we collect our like terms, we now make M0 the subject of formula. So we are going to do what? Collect like terms. I would have MV minus what? 0.25 MV is equal to what? 1.25 M0 V. Now this one 1 MV minus 0.25 MV give us what? 0.75 MV is equal to 1.25 M0 V. Now, how do we make M0 the subject of formula? Divide both sides by 1.25 V. 1.25 V. So that means our answer will be in terms of what? M0, the stationary mass object or the stationary object we have its answer in terms of M. So this one will cancel this. This one will cancel this. So this one will cancel this. So what we would have now, M0 will now be what? 0.75 divided by 1.25 M. So this one will give us what our final answer there? It was 0.6 M. You can just press your calculator to confirm. 0.65 M. So the answer to this one is 0.65 M. So if we want to, let's clean this other side first. We know that we are done with this part. We are done with this part now. Number 7 is done. And let's clean this one to also have more space for us have more space for us to solve. Okay. Now, what I want to do next is what? Number 8. We are solving number 8 next. He said a rocket in deep space turn on its engine and eject what? 1%. So rate of mass is what? 1% of what? Mass per unit. Let's say mass per unit time is 1% of what? Mass per unit time. With an ejection velocity of what? What is velocity? Velocity is given as what? What is ejection velocity? 2200 what? Meter per second. What is the initial acceleration of the rocket? So we are looking for A0, initial acceleration. Whether I call it A0, you call it AI, anyone, A prime, it depends on you. So that is what we are looking for. We are looking for initial acceleration of the rocket. Now let's take our mass. Since mass is not given, let the mass equal to 1 unit mass. That means 1 kilogram. So, and if what the mass is 1 kilogram, then let's take what? Mass per unit time as 1 what? kilogram per second. So our mass of what? The rate of mass now will also be taken as 1 kilogram per second. So therefore, if you multiply, what is 1%? So rate of mass now will now be 1% is what? 1 over 100 times of is times 1 kilogram per second. So that will now be 1 over 100 kilogram per second. So our mass is already known. So to find initial acceleration is equal to what? M over T times what? Velocity over what? Over M, the mass of the body, unit mass. So M over T, which is what? 1 over 100 times what? Then this one will give us what? 2,200 meter per second divided by what total mass now? We are assuming 1 unit is what? 1 kilogram or 1. So this we cancel this we cancel this. So initial acceleration is equal to 22 what? Meter per second square. So that is our initial what? Acceleration of the question. Question 8. So we have solved question 8 now. So the initial acceleration of that question 8 of the rocket that in deep space that turns its engine and ejects 1% of its mass per unit length with an what? Injection velocity has an acceleration of what? 22 meters per second. Number 9. Let's look at number 9. And number 9 will take us a very short time, but a technical kind of question. Let's look at it together. Now, what is number 9 saying? Now, number 9 is saying a truck moving with a velocity of 10 meters per second to the right hit a bicycle also moving to the what? To the right with a what? A velocity of 6 meters per second. So that means that from that first information, now we are going to get U1. Let's say U1 is 10 meters per second. This is for the truck. This for the truck. Then for the U2, which is for the bicycle, is was 6 meters per second. Both of them moving in the same direction. Now after collision, the truck and the bicycle move together, or they move rather to the right with what? A velocity of what? So velocity of this one, V1 is now what? 6 what? Meter per second. And the what? That of what? This is for the truck and this is for the bicycle. Now V2 is now of 5.5 meter per second. So what they say respectively? What is the coefficient of restriction? So E is what we are looking for now. It's equal to what? V2 minus V1 over U2 minus U1 absolute. Let's not forget the absolute place. So that will give us what? V2 is what? 5.5. V1 is what? 6 divided by what? What about U2 is what? 6 minus what? U1 is 10. Absolute. So what we're going to do now is, well, this one, the up one will give us what? Minus what? 0.5. The lower one will give us what? Minus 4. Absolute. This minus becomes minus, but when you take absolute of what? 0.5 divided by what? 0.5 divided by 4. And that will give us what? 0.125. So the answer will be 0.125. So that will now give us what? 0.125. So it does not have a unit. So the coefficient of restriction for number 9 is 0.125. Now let's solve. Let me create more space because this one will take more time. Not time rather, but it will take more space because we have multiple questions under it. Now the last one for this particular section is that was it what? A truck. Let me clean this part also. Okay. We are done. We are done with this. So we are not solving a truck again. Sorry. It's supposed to be number 10 now. Number 10 says what? Number 10. So what is the magnitude of what? What is the magnitude of the momentum of a momentum of a what? 1,000. So we have mass as what? Is it 1,000 or 10,000? 10,000 kilogram mass truck whose velocity is what? What velocity? 15 meters per second. Now that is the first question. Let's solve it first. What is the magnitude? That is question A. So the momentum P is equal to what? mv. Mass times velocity. Don't forget what is also equal to impulse, provided the initial velocity is 0. Yes, it's equal to impulse. Impulse is force times time. So this one will be 10,000 times what? 15. What do we have? I would have 15 what? 0, 1, 5, 1, 2, 3, 4. Or 150,000 meter, kilogram, meter per second. So our answer will now be P is equal to 1.5, 1, 2, 3, 4, 5 times 10 raised to the power 5 kilogram meter per second, or Newton seconds, anyone. Now that is A. Let's go to B. B says, well, what speed must a 5,000 truck attain in order to travel? Number 1, Roman figure 1 or B now, said the same momentum with that 10,000. So if you have to do that, you are going to use Newton's third law. Say M1 V1 equal to what? M2 V2. Application of Newton's third law. So now, in this case now, our M1 is what? 10,000. V1 is what? What is our V1? 15. M2 is what? 5,000, which are looking for what? The V2 times V2. So divide both sides by what? 5,000. This one will cancel this. Cancel this, cancel this, cancel this. So 5 here 1, 5 here what? 3. So I want to have what? V2 is equal to 30 meters per second. So that this velocity of the what? Of the 5,000, the speed of 5,000 kilogram truck in order to travel at the same speed as the 10,000 truck. Now let's go to the second one, the last one, the part B. Second one, B now, second one. It said the same energy, same kinetic energy, specifically kinetic energy. What is kinetic energy? For them to have the same kinetic energy, it means that half M1U what? V1 square or equal to half what? M2 V2 square. Then they must have the same kinetic energy. So let's say this one cancel this. So that is it. Now, for it to have the same kinetic energy now, the same kinetic energy, that means that no need to cancel self, no need to stress myself. They say what speed must what? Yes, what speed? That means I'm looking for V2. What speed must this 5,000 kilogram truck have or attain in order to travel at the same kinetic energy? So I'm looking for V2 now. But you know that this V2 here will be different from this one. Let's solve. You see it clearly. So we can say cancel. So we now remain what? M1 V1 square equal to M2 V2 square. So this one will give us, what is this one now? Is 10,000. M what? 1 is 10,000. So V1 is what? 15 square. M2 is 5,000. Then times what? V2 square. So we divide both sides by what? 5,000. So 5,000. So what do we have? This one will cancel. This will cancel. This will cancel. So that will give us what? 2 times what? 15 square equal to what? V2 square. Now what I want to do is to take square root of both sides. So if you take square root of both sides, what I want to have is what? Is the root 2 is what? If you take square root of the 2 is 1.414 times what is the root 15 square is 15. Is what is root V2 square now be V2. So our V2 will now be equal to what? Just check the mic. So 15 times what? 1. That should be 21.2. 15 times what? 1.414. Let's check. Let me show. 21.21. Okay, so I'm correct. That should be 21.21 meter per second. So that will give us the final answer for the what is second part B of this question. I believe we have finished this section. I'll finish it well. So please subscribe to watch more of the session on momentum. I still have more, maybe 1 or 2 sections to go to finish this question, every kind of question, on momentum. Thank you very much. God bless you.